Have you ever stopped to think about what's actually powering the AI that's changing our world? Well, you're in the right place. Today, we're diving deep into the brand new engine built for that massive demand, AMD's Instinct MI350. We're going to break down how this incredible piece of technology really works.
But before we get into the hardware, let's just step back and ask a really basic question. Why is this happening now? Why has the need for computing power just gone through the roof in the last couple of years? What exactly changed?
And, well, here's your answer. Just look at this chart. The wild thing isn't just that the line is going up, it's the shape of it. That's not a gentle hill, that is a vertical wall. The AI models we're all using are getting exponentially more complex, and that's creating this almost bottomless pit of demand for hardware that can keep up.
So that brings us to the specifics. What does this AI explosion actually demand from the hardware? For generative AI to do its thing, what does it need to thrive? It really comes down to these 5 things. First, you need insane memory bandwidth. Think of it like a giant fire hose for data to keep the chip from ever getting thirsty. You need huge memory capacity just to hold these enormous AI models. The little calculators inside, the ALUs, they have to be ridiculously fast. And of course, the whole thing can't melt your data center, so it has to be power efficient. And finally, you need a way to link tons of these things together for training new models.
And that, right there, brings us to the star of the show. This is AMD's answer to that massive challenge, the Instinct MI350 series.
Now, to really appreciate the MI350, you gotta see where it came from. This thing didn't just appear out of thin air. It's the latest step in a really consistent year-over-year pace of innovation from AMD. You can just trace the line right here, from the MI200 back in 2021, straight through to today's MI350. It's a clear pattern. Okay, so to really wrap our heads around what we're talking about, we're going to go on a little visual journey. We're going to start at the huge data center scale and zoom all the way in, right down to the microscopic heart of this machine. So we start here at the highest level. This is an industry-standard rack you'd find in a data center. It's just jammed full of servers. And in this setup, it can hold up to 128 of these GPUs. Shoving this much power together so tightly is absolutely critical for training those gigantic AI models we were just talking about. This is literally the engine room of a modern AI factory.
Now let's punch in a little closer. One of those massive racks is built from these individual server nodes, just like this one here. This is the fundamental building block of that whole computing structure.
And inside that node, we find this, the Open Compute Accelerator Module, or OAM board. This is basically a standardized board that lets you plug these incredibly powerful chips into all sorts of servers. This is where the real horsepower lives. We're getting really close now. And here we are. After zooming past the rack, the server, and the module, we've finally arrived at the AMD Instinct MI350 package itself. This beautiful, intricate stack of silicon is our final destination.
So after that whole journey, you have to wonder, just how complex is this thing? Well, get this. It has 185 times billion transistors. That's a number that's almost impossible to even imagine, all packed into this one single component.
So the next logical question is, how is that even possible? How do you do that? Let's unpack the architecture a bit to see the key ideas that make this level of performance a reality.
So the secret sauce, the big idea, is something called chiplet technology. Instead of trying to build one single, gigantic, fragile chip, which is incredibly hard to do, you break the problem down. You build smaller, specialized modules, or chiplets. It's kind of like building with super advanced Lego blocks, where each block does one thing perfectly.
And here are those Lego blocks in action. The MI350 uses 2 main types of chiplets. Over on the left, you've got the I/O die. Think of this as the traffic cop. Its whole job is to manage all the data flowing in and out. Then on the right, you have the accelerator complex die, the XCD. That's the powerhouse, the engine that does all the heavy lifting for AI. By splitting up the jobs, you can make each piece better, more efficient, and easier to build. It's a totally modular approach.
Now, when it comes to AI, memory is everything. It's king. The MI350 is packing a whopping 288 gigabytes of the latest HBM3E memory. That HBM stands for high bandwidth memory, and it's physically stacked right on top of the processor. With a peak bandwidth of 8 terabytes a second, the payoff is huge. It means these giant AI models can live entirely in the GPU's memory. No more waiting around, this slashes latency and makes AI responses way faster.
All right, We've seen how it's built, but now let's talk about the fun part. What can it actually do? It's time to put some numbers on the board. We're going to look at this in 3 key ways.
First up, the generational leap. Compared to the chip that came right before it, the MI300X, this new MI355X gives you about a 3 times performance boost for inference. That's when you're asking the AI questions. A 3x jump in a single year is just massive.
Okay, next question. How does it do against the competition? Well, according to AMD's own numbers, when running certain large language models, the MI55X comes out ahead of its main rival, the NVIDIA B200, by up to 1.3 times.
And finally, we have to talk about training. This is the super heavy-duty process of actually building new AI models, and here, the MI355X delivers up to a 3.5 times boost over the last generation. This kind of speed-up is exactly what researchers need to invent the next wave of AI.
So after all that, you just have to wonder, right? What comes next? Because if there's one thing we know about AI hardware, it's that the innovation isn't just relentless, it's speeding up.
And this chart says it all. Look at that performance curve over time. It's been climbing steadily for sure. But then, look what happens with the next generation they've announced, the MI400 series. The line goes almost vertical, so the pace of improvement isn't just linear, it's actually accelerating. And that brings us to our last thought for today. We've seen the hardware, we've seen the architecture, and we've seen these unbelievable performance gains that are happening year after year. So it really just leaves us with one big question. With computing power accelerating this fast, what problems are we going to solve next? What breakthroughs are just around the corner?